common failures associated with the variable geometry turbochargers are related to damage to the ring plate, the blades, or vanes, and the connecting rod mechanism. It is somewhat common to pull the turbo apart and clean up rust and soot that causes the vane system to bind and cause drivability problems. Turbochargers can be damaged by dirty or corroded oil, and most makers recommend more frequent oil changes for turbocharged engines. Many owners and some companies recommend using synthetic oils with a higher fluidity when cold and do not break down as quickly as conventional oils. Because turbos heat up when running, it is recommended to let the engine idle for up to 3 minutes before shutting it off if the turbocharger was used shortly before stopping. This gives the oil and the lower exhaust temperatures time to cool the turbo rotating assembly and ensures that oil is applied to the turbocharger, while the turbine housing and exhaust manifold are still very hot. Otherwise, coking of the lubricating oil trapped in the unit may occur when the heat soaks into the bearings. This causes rapid bearing wear and failure when the car is restarted. Even small particles of burnt oil will accumulate and lead to choking the oil supply and to failure. This problem is less pronounced in diesel engines due to higher quantities of oil in the crankcase. A turbo timer can keep an engine running for a pre-specified period of time. This automatically provides a cool-down period. Oil coking is also eliminated by foil bearings. A more complex and problematic protective barrier against oil coking is the use of water-cooled bearing cartridges. The water boils in the cartridge when the engine is shut off and forms a natural recirculation to drain away the heat. Nevertheless, it is not a good idea to shut the engine off while the turbo and manifold are still red hot. In custom racing applications, utilizing tubular headers rather than cast iron manifolds, the need for a cool-down period is reduced because the lighter headers store much less heat than heavy cast iron manifolds. Newer ceramic manifolds take care of this issue most efficiently.